Hello, welcome back to all my subscribers. And if you're not a subscriber, what's wrong with you? Right, so this is just another update on my emulator program and more my assembly level program. Now, if you watch the last program in this series where I was struggling to fit the instructions and the data set from an assembler into the same sort of binary file. Well, if you're familiar with this sort of stuff, you were probably already screaming at the screen, don't use a binary file, you idiot. Yeah, fair enough. And eventually, after a lot of research on various file formats, I discovered that yes, I was being an idiot, and no, I should not be using a binary file format. So what I did was I worked out that what I should be using is a hex format. Now this is the Intel hex format that is a standard for a long time. I'll just briefly show you this, but this is the Intel from Wikipedia, and it goes through the file format, and it's relatively straightforward. You have a start code, a byte code, the address which you're going to load the data into, or if you're not going to load it, it's all zeros, the record type, the data, and a checksum. Now on mine, I left out the checksum because I just don't need it. I'm not transmitting it, so I don't care about that. I've used a custom record type, which is possible to use, but basically normally this is used for data, but I'm using it for instructions as well. So let me just show you that quickly. If you look at this line here, this first one is all instructions. So what you can see by looking at this is we have the colon, which is just basically saying that ignore everything before this line, and there is nothing before this line. Then 10, which is the byte count of the data in hexadecimal. So this is 16, basically. And then this next bit here is the address. Now, because this is instructions and I'm letting the emulator pick where it wants to load it, I've set this to zeros. And then this is the record type, and I've picked 11 as a custom record type. And then I put in 4-character hexadecimal instructions because I have 16-bit instructions. So these are the instructions for this program over here. So this is being translated into that. So this bit here is this first line, and a jump to FFF is basically 50 FFF. Now the data section, the first line is this message, hello world, which pretty simple, but what you can see here is we've again got the hexadecimal 10, so 16 bytes of data. I want it to be loaded into 00AD in the emulator. So in this example, I'm giving it an actual address that I want it to be loaded into. And then I start giving it, then there's the 00, which is the record type for data. And then I just start giving it the address. Now, these are not 4-character hexadecimal. These are only 2-character hexadecimal because in this example, I am only loading 8 bits, not 16. So the instructions are 16-bit longs, but data is only 8 bits. So I can just get away with doing the 2 here. And I think that's 72 in decimal. Yeah. And then, so basically this is writing out here. This is effectively hello world with a carriage return. And then goodbye cruel world is this one. And that is getting loaded into BA. And then this is a standard end of file marker. So this is just copied and pasted straight in here at the end of my code. So when I do the assembler, it literally just puts that in on that last line, and that's it. So that's all it does. And then I've reworked the whole of my load file, so I now load this hexadecimal file instead of a binary file. And if the instruction set is 17, which is 11 in hexadecimal, then it will load all the memory instructions into the first available memory space, which it checks up here somewhere. Yeah, get the first available memory address. Otherwise, if it's data, it just loads it into the address it was directed to. And then if it reads the 1, which is here, then it's into file, so just quit. So it's relatively straightforward, a lot easier to load this, and also I don't have to pad it with zeros or any kinds of madness to get this to work. So this is much easier than what I had before, and I'm sure everybody was just screaming at the screen, you know, you're an idiot. But fair enough. But in addition to being an idiot, I'm also an author, and if you want to help my page out, my channel, it would be really helpful if you could check out XGI Publishing and see if you like any of these books. And if you do like the books, follow the link and buy them, and it helps me out a lot. Right, well, that's pretty much it for today. You know, there's nothing else for me to describe. Please like, subscribe, notify, and share these videos out if you like them. You know, it helps my channel a lot if you help share it out and get other people to subscribe. So that's it for today. Thank you very much. I really appreciate your attention. And if you like this series, tell me in the comments. I'm sort of hesitant of whether I'm going to carry on or not. So, you know, if you want to encourage me to keep doing this and keep showing you the videos, then let me know in the comments. Because otherwise I'll probably give the rest of it a miss. But, you know, there are a lot of things I still need to implement. And if you want to see that, then I will keep doing the videos. I think my next thing that I want to do is I do want in the command line interface, I do want to have the ability to do print, sort of printf calls, fputs calls, things like that. So that's my next step. Now that I've got this loading data correctly, I'm going to get it to the point where, you know, I can do, you know, call, you know, jump printf and get it to print, you know, the message in R0. Okay, thank you very much. Thank you for watching, and I'll see you again soon.